Welcome. Today, we're going to break down a math concept that seems simple on the surface, but has some seriously explosive power: the factorial. It's a neat idea with some pretty wild implications. So let's kick things off with a little puzzle to get our brains warmed up. Let's say you've got 3 books. How many different, unique ways can you line them up on a shelf? It sounds simple, but the answer to this question gets us right to the heart of this whole thing. Okay, so to solve that book puzzle, and a whole lot more, we're going to need the right tool, and that tool, my friends, is the factorial.
All right, here's the official definition. Whenever you see a number with an exclamation mark after it, like n, it's just a shorthand way of saying, take that number and multiply it by every whole number below it, all the way down to 1. It's basically a big multiplication chain, and it's the absolute foundation for figuring out things like probabilities and combinations.
Now, here's a weird one, but it's super important. 0 factorial is equal to 1. It might not make sense at first, but think about it. How many ways can you arrange nothing? Well, just one way, right? By having nothing. And this little rule, it's actually the key that makes a whole bunch of other important math formulas work just right.
Okay, enough theory. Let's see how this thing actually works with some real numbers. It's always better when you see it in action. So check out this table. It lays it all out for us. You can see 1 factorial is 1, 2 factorial is 2, and 3 factorial is 3 times 2 times 1, which is 6. And there's our answer to the book question. 6 different ways to arrange those 3 books. But just look at how fast these numbers are climbing. We're only at 5 and we're already over 100.
The process itself is super straightforward. So for 4 factorial, you just take your 4, multiply it by 3, that gets you 12, then multiply by 2, you get 24, and times 1, of course, is still 24. Boom, done. All right, so that's the math on paper, but what if you wanted to get a computer to do this for you? How would this actually look in code? Let's take a peek at how you do it in Python. So in Python, you've basically got 3 main ways to do this. You can build it yourself with a simple loop. You can use this kind of cool brain-bending method called recursion, or you can just do it the easy way and use a function that's already built right into Python. So first up, we've got the iterative approach. Honestly, this is pretty much exactly what we just did by hand. The code just loops through the numbers one after the other, multiplying as it goes, building up that final answer step by step. Super direct, really easy to see what's happening. Okay, next up is recursion. And this one, it's a little bit of a mind bender. The best way to think about it is like one of those Russian nesting dolls. The function basically calls itself with a slightly smaller number, which then calls itself with an even smaller number, and on it goes until it hits the tiniest doll, that's our base case, of 1. Then it all unwinds, multiplying all the numbers back together on the way out. Pretty clever, right? And then there's the easy way, the why do it yourself method. Python has a built-in math library, and guess what? It's got a factorial function just waiting for you. You just import it, call it, and bam, it does all the work. Seriously, for most situations, this is the one you're going to use.
All right, now let's get to what I think is the coolest, most powerful part about factorials. They're absolutely insane growth. Here's the key thing you got to understand. Factorials don't just grow, they explode. This isn't like adding 2 plus 2 plus 2. It's multiplicative, and that makes all the difference. When that starting number n goes up by just a little bit, the final result gets astronomically bigger. It's why trying to calculate, say, 100 factorial will make most computers break a sweat.
Let's just look at the numbers. So 4 factorial, we're at 24. No big deal, right? A pretty manageable number.
But watch this. We go up just one notch to 5 factorial, and suddenly we're at 120. Whoa, that's a huge jump. It's 5 times bigger. Okay, let's go one more step. 6 factorial, and we've rocketed up to 720. You see that? The gaps between the results are getting wider and wider. It's accelerating like crazy.
This chart just says it all, doesn't it? I mean, look at those bars. The jump from 2 to 6 is one thing, but then the jump from 6 to 24? It's huge. And that curve is just going to get steeper and steeper, basically going straight up as the numbers get bigger.
And that really brings us to the big takeaway here. See, the factorial isn't just about arranging books. It's a mathematical concept that perfectly describes this pattern of explosive growth, a pattern you see all over the place. It shows how possibilities can go from manageable to practically infinite in just a few short steps. So I'll leave you with this question to chew on. Where else do you see this kind of explosive growth in the world around you? Think about technology, nature, even social trends. Where else is this powerful pattern at play?